Hello, I'm Cade Mendelowitz, Professor of Lighting Design and author of Theatrical Lighting Design Interactive. This is an introduction to Lightboards. This board happens to be an ETC Express 250, which I'll use to demonstrate what many Lightboards are capable of. But I'm more interested in focusing on what you can do and some of the terminology used by Lightboards. Most brands, and even different boards within those brands, are capable of similar functions, but how they work to achieve these effects often work differently. Modern Lightboards use DMX, which is a control language that I cover through 2 different videos on this disc. Let's start with an overview of what Lightboards do. Generally, Lightboards do not control lighting instruments. Typically, units are plugged into circuits. Circuits are then connected to dimmers. Dimmers are connected to large amounts of power and are controlled by Lightboards. So, most Lightboards really control the dimmers, and the dimmers control the power supply to the lighting fixtures. That said, there are some small Lightboards, generally used in very small touring situations, where dimmers are built into the Lightboard. Those Lightboards are usually very small in capacity. Generally, they can only control 6 or 12 dimmers. Those are very limited and are not typically used in theaters. Lighting fixtures are spread throughout the theater and are plugged into circuits which are numbered by position. Sometimes these circuits are part of a dimmer per circuit system. Either way, the sequence of those numbers usually makes sense architecturally, but not for the various designs we implement. To make it easier for designers to make sense of the lights, their control can be reassigned to channels. Traditionally, designers would have to use something like a hard patch of some type. The most popular format was known as a spaghetti patchboard, which resembled an old-style telephone operator's panel. You can see that it received its nickname from resembling the visual haphazard nature mess of a pile of spaghetti. Thanks to computer boards, we have what's called a soft patch, which allows you to control 1 or more dimmers by means of control channels. Oftentimes, in order to keep as much subtle control as possible during cueing, designers choose to only put 1 dimmer per channel. In the case where a designer is confident they won't use just 1 instrument, however, it can be easier to gang multiple dimmers together. A prime example might be a wash that doesn't need fine control, like a Farsight wash. In this case, there are 8 individual instruments with 4 colors each, which uses 32 total circuits and dimmers. But in the case of a typical show, the designer wouldn't normally need to control the individual cells of blue, for example. So, designers often choose to consolidate each of the color washes into a single channel, giving control of the 32 individual lamps to just 4 channels without actually losing any control that might be desired. Even individual instruments are typically patched into channel controls that are easier for designers to manage. For example, if we were to leave the straight-on front light in this show as the dimmers that they were plugged into, to bring up a wash of all of the front light, we would have to call out dimmers 1, 4, 12, 18, 27, 43, 44, 53, 62, 65, 68, 75, 85, and 96 to full. By rearranging their control through channels, we can simply bring up channels 1 through 15 at full. Easier to remember, less buttons to press, and faster to implement. We can also decide to channel each of the acting areas in a similar fashion. So by starting with the number 1 in area A, we can proceed sequentially until area P is now channel 15. For the downlight wash, however, a designer may choose to start with number 21 in area A. Sequentially, area P ends with channel 35 then. Now, however, if we need to bring up area B, we may remember that B's are the 2s, meaning that front light is 2, down is 22, side light is 42, and backlight is 62. This is just one example of a format I often follow to make queuing easier to manage. So right now we're looking at the stage. We can switch to patch. And as you can see, nothing's been patched in yet. Here's our list of channels, and there are no dimmers listed. So let's start patching in some dimmers. Now on this board, it gives you some instructions on the bottom, which is very nice, but not all Lightboards do this for you. So now you can see that I've put different dimmers into different channel numbers. These are the same dimmers that I talked about earlier, except now they'll be in a sequential order that makes more sense since we're not dealing with the architecture of the building. We can also put many dimmers into the single channel, as I said before with the example of the Farsight wash. Let's go back to the stage and take a look at how these operate now. Once the patch is in place, we can take this organization one step further. For example, we can make groups of channels or program them into submasters. For example, let's bring the full front light wash to full and program them into a submaster. On this board, this is achieved by recording the submaster. So channel 1 through 15 at full, record sub 1, enter. Now on this board, channels are color coded, so we can see that the active channels are shown in red. If I were to modify any of them, they would show up here, but if I try to operate the submaster, it doesn't look like it's affecting anything. That's because I still have them up on the keyboard. That's what's known as being captured. If I release that, nothing's on stage right now, but I can see, now I have full control using the submaster. This board also has bump buttons, which is basically like a momentary contact switch. If I push the button, it brings all of those channels up to whatever level I recorded it at. Let's record a few more. 21 through 35, full, record sub 2, enter, release. And then channel 41 through 55 at full, record sub 3, enter, release. So now I see that I have 3 submasters fully recorded. We can complete the series with all of our main washes. So if we want to create a queue that takes place over the entire stage, we can now adjust just a few submasters and then record that queue. Slider 1 at 70%, slider 2 at 50, and slider 3 at 80. On this board, to record a queue, it's quite straightforward. Queue, we're going to record queue, enter the number that we want to record it in, and enter. So I've just recorded it as Q10. Notice it's recorded the new Q10 and assigned it to the default crossfade time of 4. We can change the time, and on this board, we can even change the default time. So if we knew we wanted all of our queues, typically, to be a count of 5, we could preset that. Let's make a few more queues and then look at how fade times work a little more closely afterward. Right now our sliders are still up from where I put them for our Q10. Well, let's say that we wanted to modify one of the areas who has a channel already up. We can set that channel to be a specific level, and that setting will override where the submaster is telling it to do. So let's bring area A to full. Channel 1 and 21 at full. If we wanted to make our area stand out even more, we can dip the areas right next to it. So let's bring down areas B and F by taking channel 2 and 22 and 6 and 26 to 30. If we're happy, we can go ahead and record this as Q11. If we wanted to affect a range of channels, we can use the through button. Let's take the rest to 0. So 3 through 15 and 23 through 35 and 42 through 55. Now I have captured control over all of those groups of channels. This board conveniently gives active channels that I'm currently working on a different highlighted color on the display. And you may notice that while I was easily able to not select my area A and B lights, I have selected my area F lights. I can use the Accept key to deselect channels 22 and 26 now. I say add 0, 0, and it takes down the remaining units. So you see I've made a very bright area A. Their nearby area is less bright and taken everything else out. Let's record this as Q12. Now that I've saved a few cues, let's play them back to see how that section of the board works. First, I need to release control of the channels that I currently have captured. Otherwise, when I load the cues, it won't show us what's happening. I also need to take down the submasters. Many computerized lightboards have a few sets of crossfade controls. The main one is usually the AB fader. To bring up Q10, we'll tell the board, Q10, go. And you can see that it took 4 seconds for that cue to fade in. This board also assumes you want to proceed in sequence. So it's telling me that we're in Q10 and that Q11 is what will come next, and that it will take 4 seconds for that cue to fade in. The channels are also reflecting what's actually happening on stage. So if I hit the go button, you could see the fade progress and the lights change on stage. Once it's complete, you can see that Q12 is ready to come next again in 4 seconds. Perhaps we realize that we made a mistake, however, and that we shouldn't have gone into the cue already. We can easily hit the back button to crossfade back to the previous cue, in this case to Q10. Again, it takes 4 seconds for that fade to happen. Now let's say that 4 seconds is good for the first cue, but we want Q11 to take only 3 seconds to take over. We can reset that by saying Q11 time 3. For now, we'll set our fade in and fade out times for the same number 3. Perhaps we want Q12 to run automatically, so that 2 seconds after the lights are intensified in area A and the rest of the stage goes dark. For that, we can set an autofollow by linking Q11 to Q12 with a wait time of 5. So I'm linking it to Q12 with a wait time of 5. So now, when we go into Q11 by hitting the go button, the light board keeps counting and then automatically crossfades into the next cue. Most computerized light boards have ways to set linking and autofollow, though they vary greatly on how that's accomplished. And Different boards have different meanings for up fades and down fades, which is why we're not going to talk about those at this level of introduction. A few things to note. Now that the patch and our cues are programmed, it's a good idea to save the show file to disk. On this board, the disk commands are accessed through the Setup menu. Then, disk functions. This board uses floppy disks, but modern boards now have USB ports, so you can save the show to a jump or thumb drive. We were using Submasters to group a bunch of channels together, all at the same level. We can also record more complex cues into Submasters, and oftentimes it may be easier to run an event using just the Submasters. For example, an award ceremony or lecture presentation. This will allow you to quickly adjust the lights to follow the unpredictable nature of those events. Using the Autofollow, or linking of cues feature, we can also create complex effects, or loops of effects, so we can have a lightning crash or fire simulation programmed by making each phase or step of the cue effect in its own cue, then linking those cues together. Some boards also allow you to program in effects so that the board will take care of randomizing the patterns of light. They typically work by having you set which channels should be involved in the effect and what the high and low settings for those effects should be. The programming for those types of things vary greatly by every light board I've come across, and some of them don't have those functions built in. So it's best for you to check the manual of your particular light board. Be sure to check out the videos about DMX elsewhere on this disk, which contains an introduction to intelligent and moving light fixtures. Again, we've only scratched the surface of what this board can do, but these are the basic functions that most every computerized light board can manage, although the exact programming procedure varies greatly. Good luck, and try experimenting with the light board at your facility.